Well, hello everybody. Long time no see. Haven't been making videos lately. You know, it's summertime. Of course, you got all those things going on with the family and everything. And of course, work has just been really busy. And I anticipate that it's going to be very busy throughout the summer, or most of the summer. So for the next month or two anyways, not going to be doing a lot of videos. But I'll try to get down here and do little things like this every now and again, and keep in touch with everyone. So I thought today would be a good project, would be this little Zenith radio, and it's kind of unique. It's very common. You can find these online very easily. I'll give you the model number here in a minute. I have printed out all the prints and everything. This radio has been worked on, and it, as you can see, does not have the right kind of power cord or anything like that. I don't know to what extent or what all needs done to it, but I do know that the radio loses sensitivity after it's been on for a while. So either a capacitor is leaking, or one of the tubes is bad or something. But really, the reason, you've all seen a bunch of restore and repair videos on these old tube radios, but this one's a little bit unique in that it's got FM on it, and it's a very early Armstrong version of FM, I believe. Just as I say that, I'll probably be wrong. Well, a lot of the lettering is kind of worn off, but it's as you can see down here, it's a model H725, and it has an old slug-tuned FM section, and it uses an original the original design ratio detector. And it's pretty interesting to do the alignment on, so it's kind of different than doing your average AM broadcast tube radio from this era. So if this sounds interesting to you and you'd like to follow along on this, you're certainly welcome. Stay tuned, and we will absolutely get this thing cracked open after we give it a little test. Want to see what all it does, and then get it open and see what we can do. Okay. I do know that this radio works, but I'm still going to not take too many chances, and I'm putting this onto the dim bulb tester. Now, I know a lot of you have seen me use that in previous videos, but essentially all we're doing is we're taking the power cord and we're putting a light bulb, 110 volt light bulb, right in series with the power cord. So if a capacitor is shorting or something's going wrong, the bulb will take the abuse and not the radio. So let's turn this on now that we're on our dim bulb, and you can see up here, here's our light bulb. Turn it on, and you can see the little glow, and I don't know if you picked that up on the camera or not, but that just means that the capacitors were the surge current of the capacitors and or the vacuum tubes inside. I don't know what kind of rectifiers in this, if it's selenium or what it is, but anyways, those are the filaments and just the surge current of the radio turning on. But the fact that it died back down and went dim tells me there's no shorts. So let's see what we get here. Now, of course, I have my bench turned on, so we're going to get a lot of static, but I should be able to pick up my little AM internal radio station here. There it is. And in case you didn't know, this little knob here is a tone knob. So like I said, this is a unique radio. Your volume is on the right. Your band select is the front knob, FM and AM, and your tuning is the outer ring. Really odd. And then this middle medallion here is your tone control.
Lower, go back. If you fly with Joyce McCurry, make sure both of you have included your Social Security numbers and both of you have signed to return. You'll find
Let's turn off the bench.
Questions and an
There we go.
guide from your Stars and Stripes bookstore. Available now. Counting down America's popularity.
And you can hear the radio was real strong when we turned it on. I keep
continuing our
it's starting to get like a distortion. And you can see it's already starting to, the sound is starting to get really distorted and weak, and it's fading. Now I know the compression and so forth on the microphone here compensates, but what I'm hearing is it's getting progressively quieter. And when I turn it up, you can hear how distorted it is. So probably it's a vacuum tube, but it could be a leaking capacitor throwing the bias off on something also. So I do see now that the radio is up and running. The dim bulb, you can't really see it on the camera, but you can kind of see that the dim bulb is in fact lighting up a little bit brighter, which kind of tells me that probably one of these tubes is starting to overheat. So with that in mind, we're going to shut this down, and that's why we use a dim bulb, and we're going to take it all apart. So let's get the service manual out for this. They're pretty readily available. You can go to www.nostalgiaair.com, nostalgiaair, nostalgiaair.org, I believe is what it is. nostalgiaair.org is what I think. Just do a Google search, you'll find it. And you can get many of the schematics and service manuals for all of these kinds of radios. Now, Zenith is one of my favorite old American radios. They're just super well built. My dream one day is to get one of the old Tombstone AM shortwave radios with the shutter dial. Sometimes they call those radios the Walton radio. There was a TV series back in the 1970s here in America called The Waltons, and it was a television series about a family that lived up on a mountain. This is all fictitious. A mountain in, I believe it was in Virginia, called Walton Mountain, and whenever they listened to the radio, with the time frame of the TV series was set like in the 1930s and 1940s, and whenever they would listen to the radio, it was one of those really nice Zenith shutter dial Tombstone radios, and I've always wanted to have one of those and do a restore on it. So who knows, maybe someday I'll happen upon one and we can fix it up. But anyhow, enough blabbering about that. Let's take this apart and get some schematics out and really get into some of the uniqueness of this particular Zenith. We have the cover off now, and I have the chassis out in the open here. And let's go over a couple of unique things, and then I'm going to go over a couple other things that you might be interested in knowing about these particular types of radios. So first of all, this is a series strung radio, just like your old All-American 5s, meaning that there is no power transformer. The vacuum tubes all have their filaments in series, and they add up to the amount of voltage that your incoming mains line has when you rectify it half wave, which is about 140 some volts usually, 130, 140 volts usually. So all the filaments have have different voltage ratings, and they're all strung in series, but they all draw the same current. That's the whole thing. When you do a series strung circuit, you have to make sure that your filaments at their rated voltage all draw roughly the same current. or it will throw the whole string off. So that's the big thing when you do a series strung set. The other thing you'll notice here is if you take a look, this has a really nice good sized speaker in it. What is that? Is 8-inch or 6-inch? What is that? Yeah, it's 7-inch. It's a 7-inch speaker, which it really sounds nice. And strangely enough, like I said, the tuning dial attaches right here. It's just a push on, you can see. And again, this little center knob, this is your tone control. So there is a tone control, but why they mounted it that way, I don't know. It's very unique. The other thing is, if you look over here, these 3 little rods sticking up, those are your FM tuning slugs. And if I zoom in a little bit, let's take a look. If I zoom in a little bit, you can see these springs that hold this plate down. And as you tune, you can see it rocks that plate up and down, which in turn moves the slugs in and out. Now on the side, you also have the traditional, getting out of the shot here, you have the traditional capacitor here, tuning capacitor, with your plates. So very interesting how this all works. Now, here's a couple things you need to know if you're going to work on an H725. First of all, for the power cord, you have this is the inside of the back cover. And you can see in here you have this strange little connector plug, and one pin is larger than the other. This is a safety interlock. So basically what that means is when you pull this back off, it removes power from the chassis so that you can't run it with the back off. So you kind of have to put that on there to use it. And you can see this is a piece of speaker wire, which is probably not the greatest idea for power cord. So we're going to put a proper power cord in here. And since it is polarized, if you look, you have a large and small pin. We can, in fact, put a polarized power cord in here, and we're going to rewire it to do that, to make it a little safer and a little more modern. We'll get more into that later. Now, the other thing, here's what you really have to know about these. I'm going to put the schematics. If you look at the radio schematic, the radio schematic that I have here, it says model H725, and if you look, it is in fact a model H725. However, the story does not end there, because in order to really know what you're doing here, see right here on this print, it says chassis number 7G01Z. So let's look at our chassis. And if you look, here it is. Let me turn it around, and I may have to zoom you in to see it. Here we go. And if you look right here, chassis number, come on, focus. I don't know if it'll focus here. This camera does not like, there it goes. That's better. Okay, now let's see if we can get in a little closer. Chassis 7G01Z. Okay? 7G01Z. Now, so that indicates that in fact this service manual is the correct service manual for this radio. Now, I have two schematics here. One of them is the one from that manual that I've blown up into an 11 by 17. And if you look, there's two of them. Here's the original. So this is the one that came with the manual. And if you look, chassis 7G01Z. However, here's another schematic. Zenith model H725. Oh, my bad. Yep. H725. And this one says Z1, okay? Which is a chassis 7G01Z1, okay? Now, Zenith does this. I guess the reason I'm wasting so much time on all this is when you're working on these old radios, you have to really be careful. If you just go online and you type in the word H725, you could get, you know, on your search, either one of these could pop up. If you're not really paying very close attention to that little extra word there or that little extra letter and number there, you could actually be working with the wrong schematic. Now, why is this important? Well, first of all, the tube complement changes. If you look here, your RF is the same, your converter is the same. When we get to first IF, it goes from a 12BA6 to a 12 or 6BJ6. Okay, so they use a different IF tube for the first IF. Now the second IF is okay, the limiter is okay, and we'll get more into what a limiter is here in a little bit. And then your discriminator, okay, if you look, 19T8, but this can also be a 19C8 in the newer model. But the most important thing is the 35, the power amp. In the older model, it used a tube called a 35B5. And in the newer models, they went to a 35C5. Now, if you look the specs up of both tubes, they're identical. Okay? But they are not interchangeable. The big change between these two vacuum tubes was the pinout is different. If you look at this one, okay, you have grids on pin 1, and I believe that is pin 4, and then the plate is pin 5, and the cathode is pin 2. If you look here, the plate is pin 7, and the cathode is pin 1, and filaments are pins 4 and 3, and on this one, filaments are still pins 4 and 3, okay? But what they're doing is, apparently, the wiring, this is what I heard, the wiring of the original 35B5, okay, and this is not just Zenith, this is, a lot of these old radios had this change happen to them. Apparently, if you accidentally plugged this tube into, let's say, one of these other sockets, because of the original pinout, you could put, you could somehow put high voltage, like on the chassis or something like that. So it's a safety mod that they actually redesigned the pinout of this particular tube and then changed the name to a 35C5. And the big deal is if you cannot plug one in place of the other, or you could damage the radio and the tube. So you have to make sure you match up the chassis with the particular radio that you have, and second of all, make sure you have the correct tube here, because again, if you see this by accident and you go to replace the tube and you don't realize what you have, you can really cause a lot of problems here. Now, I opened this radio up and I just so happened to see, okay, again, we verified this is a 7G01Z, which is this one, which calls for the 35B5. But when I look at this tube that's in here, and this is just how I opened it, okay, this, what's it say? Let's see if we can get it to focus. Come on. Let's focus. This is a new camera, and it's an excellent camera, but the focus leaves some to be desired. It does have a manual focus too, and I'm getting to the point where I'm ready to start using it. Let's take this tube out. If you look at it, what's it say? 35 C5. See that? That's the wrong tube. Now, one of two things has happened. The radio does play. And if we look, that shouldn't happen because the pinouts are different. Okay? So, what may have happened is they may have already made this change, or somebody somewhere along the life of this radio made this change and modified it for that other type of tube. So we don't know. But what I can tell you is that definitely this chassis is supposed to have the 35B5, and instead it has the 35C5. So that mystery we have to solve before we go any further in here. Okay, so you see, when you work on these older radios, and especially these more complicated ones, I'm going through all this so that you guys that are into radio restoring, or wanting to get into it, I should say, you who already are already know this. It's very easy to get confused and to get the wrong component. Just because your schematic, even though you think it's the right one, it's not. And even though we matched everything up, if you just saw, this tube is from the newer schematic, but the chassis chassis number is from the older schematic. So what do you believe? Okay, so let's look at some of the other tubes in here. There's your 12AU6. There is your 19T8. Okay, so that's good. If we look over here, this is a 12BA6. Okay, so there's your 12BA6. That would be right here. What is that? Your first IF, I believe this one is. And second IF should be another 12BA6. And it is 12BA6. Okay. So, strangely enough, the rest of the radio matches this old schematic instead of having the 6BJ6. Okay? And we only have a 6BJ6 at the front end here, which this should be 6BJ6. And look at that, 12BA6. And if you look here, it says 12BA6 or 6BJ6. By the time the new radio came out, they're all 6BJ6s. So see what I mean? Again, you really, really have to look at this stuff carefully. Okay? So let's open up the insides and see take some inventory in there, because once again, there could be some differences. Another unique thing you're going to see about this is that these radios actually have a shielded cover on the bottom too, to keep the radios quiet. This is a really high quality radio, the way these are built. Okay, so if we look inside here, it does look like at some point in time, at least partially, this radio has been recapped. Now what I don't know is, you can see they've put some capacitors in here. They're XY capacitors. I don't know why those are in there like that, and they're doubled up. And that really doesn't belong there, I don't think. Some of these are great big orange drops, 600 and 1600 volt. So I think we're going to take some of those out. I mean, I guess they're okay, but it's really, really overkill to use those. And then some of these were not replaced. You could see here. The selenium rectifier has been replaced with a solid state diode, just a regular diode, and that's fine. That's a huge diode, by the way. It looks like this wax capacitor here has not been replaced. Fortunately, it doesn't look like anything's been touched near the oscillator or any of that, which is good. The main filter capacitor is still in there, but by the sounds of the radio, I don't think it's bad yet. But of course, that's a ticking time bomb, and you know, those just go bad. Now, again, this is a little bit of a story that it's a non-radio story, but it's related. Hope you guys don't mind me talking here. You can hit the fast forward. But anyways, I was out on a job site last week, and it was a x-ray machine that was, this machine was over 30 years old. It was pushing 35 years old, and it developed a problem in one of the power supplies, and there's a 28 volt power supply and a plus and minus 12 and a plus 5. But anyways, on this power supply board, you had several capacitors and everything, and the board just burned up. It charred up. The tracks were all shot. So I called a parts house and found a used tested board. And lo and behold, the board came in. It looked brand new. It was in immaculate shape. It was original. No components had ever been replaced on it. All original, 30-year-old board. Everything tested perfect. So we connected the board, we put it in, turned the machine on, perfect. Everything worked perfect. No problems whatsoever. So we finished the job, closed up shop, put the covers on, and always do one last test before you leave the site, and lo and behold, it failed. Long story short, one of the 2200 microfarad 50 volt capacitors just in that short time went from a perfect capacitor to dead short, just because of its age. And that dead shorted capacitor, luckily, all it did was take out a fuse. A lot of these medical machines are very heavily fused, and because of that, we kind of lucked out. It didn't damage anything, and we were able to replace the capacitors. And of course, we did replace all the capacitors at that point. Now you may ask, why didn't you just do that in the first place? Well, a lot of times these boards, they're medical. You don't really want to modify them unless you have to. This one was supposedly tested, and it was supposed to be fully functional, and it was. But lesson learned: when you get these old machines, these old capacitors, they're unpredictable. They can go at any time, and that's why when you see something like this, that's this old, that was a radio, that was a device that was 30 years old. Imagine this, which is 70 years old. Replace the capacitors, even though they're good. I know people say, oh, it's perfect, don't touch it. No, you should replace it. If you're going to play the radio, replace the capacitors. So that's enough flapping about that. Let's get into this a little bit more and do some tests. And I'm going to just do some comparison with the schematic and see where we're at, and then we'll be back. Okay, what you're looking at right now is kind of a strange angle here of the 35B5/35C5 tube socket. And even though this is the older style chassis, it does in fact have a 35C5 wiring. So if you look here, this blue wire is going to pin 7. And if you follow it down, all the way down here, there's your output transformer, which is a pretty big output transformer, by the way. It connects right to here, which is the plate on the plate tap on the transformer. So that means this was factory. I mean, you can see that's factory wiring there. This was factory wired for a 35C5. So this is a later model of the early model chassis, okay, before they changed the chassis number. So there you go. So the other thing I noticed is we still have a wax capacitor here. We don't know why that didn't get replaced. I don't know why these XY safety capacitors are in here. This is obviously, you know, this is going to the volume pot. So that tells me this has something to do with tone or decoupling or something, and they're paired together, meaning whatever capacitance it is, it's double now. I see another little poly capacitors, and these are very low voltage, 50 volt, I think, rated is all they are, that are wired in series, probably to make the capacitance we need. So those all need to be replaced. This little bypass capacitor here is going to need replaced. And these great big 1600 volt, I mean, the only reason I'm going to take them out is because they're valuable. They're expensive. These are expensive orange drops that I could probably use in other circuits, and they're not needed in here. This circuit's never going to exceed 150 volts. So to put a 1600 volt high quality capacitor like that in there, and what are these, Spragues? I don't know. Probably they're Spragues. It's overkill, and it's really a waste of these good components. So I'm going to read basically, with the exception of these little film capacitors here that are perfectly good for in here, I'm going to do a recap again on this, even though it's already been done once. I'm going to go through and fix all that. So when we do that, we'll be back. I'm in the middle of the restoration, and I just thought I'd set up the camera real quick and show you something very interesting that I found. If you look here, coming off of the discriminator detector, this is going to be your audio going into the amplifier. And if you notice, it comes down through a capacitor and into the wiper of the volume control, the volume pot. Now, the reason I wanted to show you this, if you notice, there's a little box drawn around it, and there's a ground symbol connected to that box. And what they're talking about is one of these. And as you can see, it's a standard wax capacitor, okay? However, there's a third wire, and if you notice, it's connected to a little outer stud. Basically, there's an extra piece of foil around here that acts as a shield, and then this was tied into the chassis to ground to reduce the noise on this capacitor. So this is actually a shielded low noise capacitor for the volume control. Now, it's not as big of an issue on these newer radios, and as you can see, this cap is like just coming apart on me. It's bad. On the newer components, you really don't have to worry about that as much, because the new components are so tiny and they're spiral wound and everything, and they just don't have the problem with noise that the old wax paper capacitors had. These new Mylar film capacitors, much better. So I just thought you'd be interested in seeing that. It is okay to replace them with the regular cap, but that's what these are, and that's what that symbol is. Alright, thought you'd be interested. Welcome back, everybody. Through the magic of video, we now have all of this completed, and I'll just go briefly through with you what we did. Basically, all of those great big orange drop capacitors got replaced with standard capacitors. The death capacitor that was in there got replaced with a safety capacitor. The XY capacitor, the two-part one that was all in one, I don't know where I put that thing. It was, I took it out. It was probably good. It was a ceramic capacitor. Here it is. So you can see how it has 3 pins on it. There's basically 2 X-type safety capacitors in this little ceramic case. And because of the rewiring I did, and I'm going to go over that with you in a second, we went with just a straight across the line XY capacitor. I added a cap right here at the junction of this diode and this resistor here, and the reason being is because this dropping resistor is dropping your voltage to compensate for the selenium rectifier that used to be in there, because the selenium rectifiers always have some attenuation to them, where these only have about half a volt drop on them. The seleniums can drop 10, 15 volts. So that's what this resistor does. It makes the circuit think that the selenium rectifier is still there. But if you do not put a capacitor at this junction, the drop across this resistor will show up as a really big ripple, and that ripple doesn't get filtered very well on this end, and it really dramatically drops the voltage on the other side of the resistor. So you need to have some sort of a capacitor in here. I just put what I had. Probably a 10 or 20 microfarad would have been good. This was a 33 at 250 volt, more than adequate. So that's good. What else? So rewiring the power. If you look at the schematics on how this thing works, let's see if we can bring in the small schematic so it's easier to get on the camera. So if we look here, basically what we've got is right down here in this section, here's your incoming line. And if you notice, you had that XY dual capacitor, so you had one capacitor to ground and then the other leg to ground through that three-legged cap. And if you notice, the one prong goes directly to the chassis, and it's through the switch, so you're actually switching the chassis ground on and off. And then this one here goes straight across and goes into your rectifier and your filament string. So to make this a little bit safer, what I did was I took this and I connected it directly to chassis ground, took the switch, broke this part of the circuit and wired it in. So you can see this down here where this line is going straight to a ground lug, this line is going up here and it's going into one leg of the switch, comes out of the other leg of the switch, comes down and goes to here, as you can see right there. So that's basically what we're doing. That makes it a little safer. Now on the other end, what we're going to do is, if you notice, there is a large diameter prong and a small diameter prong. And if you look down in here, you have a large diameter and small diameter. I'm going to remove this old cord, and I'm going to install a polarized cord. Now what a polarized cord is a cord that has one prong that's actually wider than the other. And if you ever notice on an outlet, so let's look at this little outlet here, you can see one is wider than the other. This wider prong is connected to your neutral. Okay, this is your hot line right here. Okay, so neutral and ground inside your breaker box are actually physically tied together. So by connecting the wide prong of the polarized plug to the wide prong of our safety connector, or actually in this one it's to the wide prong, basically what we're going to do is we're going to ensure that the neutral line on your power cord is always connected to the chassis. So your chassis will then always be at neutral potential or ground potential. And that's really, really important, because in the old days when you had a non-polarized plug, which is what you see here, if you notice, both of these prongs, okay, are the same width. So I can plug this in to this outlet either way. Okay, I know you've seen this on other videos that I've done and on other videos that other people have done, but by doing that, it's a 50-50 chance every time you plug this in that you're connecting that neutral line to the chassis. So what's happening? Well, you're putting your 125 volt AC hot line right onto this metal chassis. If you were to touch this chassis and touch any other thing, a cold water pipe in your house, if you touch another grounded appliance, you know, like the oscilloscopes are grounded, your refrigerator is grounded, a lot of, you know, anything with a metal case, your toaster, all these things that are grounded, if you touch that, you're basically touching this, which is the hot side, and you're touching the grounded device that's the neutral or ground side, so you're putting the full mains voltage right through your body, which is extremely dangerous. So this is a modification that you can do to make this radio safer so that it ensures that you can't plug it in the wrong way. Now, of course, if somebody wired your outlet in your house incorrectly, you still would have a problem, but we're assuming that you have properly wired outlets in your house. So, and again, these are things you should know about if you're working on these kinds of devices. You know, the little disclaimer that everybody always says, you know, be careful when you work with this electronic equipment. There are hazardous voltages, you can get injured, and just know that if you're doing this, to quote some other YouTubers out there, you are doing so at your own risk. So just work safe and be careful and enjoy this hobby. So with that being said, let's back on out here and let's turn our meter on, and let's just see. I have this red line, this red wire right here, the plus of my meter, is going right to the plate circuit. So if you would look right here, we're actually looking right here on the plate wire, where right here. Okay, so it's where it comes off of this capacitor and goes to your transformer. All right, now on this one they show a resistor going to that plate tap. Oh no, they don't, I'm sorry, I'm right here, the 130 volts right here, the plate tap right here. Okay, so you have right coming straight out of here, going into here, into your plate tap, and that's this little red and white wire here that leads right up to here where our brown dropping resistor is. Okay, so that's what you're seeing. So you should see about 130 volts if you have full main line voltage going in. So let's turn this on and see what we get. Okay, there we go. All right, okay, if you notice, it goes real high. Okay, and this is because there's no load right now being drawn down on all those capacitors. As the tubes heat up, you'll see this voltage drop. See there? It's starting to go down. And as it goes down, the sound will come up. And let's turn off.
Field. So watch your newspaper for the announcement that the car of tomorrow has arrived. Then let the new...
Now that's my my little inside radio station in the house. I haven't figured it out, but somehow it is picking up line noise and inducing it onto the RF. So you can hear when I turn it up, you hear a 60 cycle or 120 cycle hum.
Sisters with a little musical advice to the lovelorn.
Always remember, girls, that
Hear that hum?
what counts.
So I'm going to have to figure out what that is, but that's for a later project.
Cool, be calm, be distant.
Again, I'm in the basement at the bottom of a hill here where I live.
Accepting responsibility.
But so far so good. It is picking up a few stations.
The bikini suit made its debut at a Paris fashion show.
And you can hear the tone control.
This week in 1946, Mother Frances Xavier Cabrini became the first American saint.
That's your look back at This Week in History.
So there you go. So our voltages are good. The radio's playing pretty well. I did not replace these couple of capacitors down here yet, these electrolytics. They are very good condition right now, almost perfect. I still may do so for reasons that we discussed earlier, because they can fail anytime. But there again, it just depends. If I end up on selling this radio, I may perhaps replace the capacitors for good measure. If I end up keeping the radio, I know how to do it in the future if I need to. I may just leave them for right now. One of the things with these radios that use diodes is if one of those capacitors were to short, you could damage some resistors. Some of these resistors will go away or get very hot, but you're not really risking damaging much else, because on the older radios that used a vacuum tube rectifier, that would be a problem. If your capacitor shorted, you immediately damaged your tube, and that's obviously something you didn't want to do. So it's a little lower risk on these solid state rectified radios. But anyhow, just to give you a little information on that. So the more exciting part of this will be the alignment, especially with the FM alignment. So I'm going to flip this over, and I'm going to get things set up to do the alignment, and we'll go from there. Before we get started here, I thought I would show you the website that you can find a lot of old radio information on, like the service manuals and so forth. Now, if you look right now, they have a little message posted that there was a hard drive failure on May the 25th, so they're rebuilding the website. So there may be some things not on here until they get it back up and running. But for the most part, the website, the address, I'll zoom in here, is www.nostalgiaair.org. Okay, there you go. So once again, very good site. So you can navigate through here. If you go to the resources section, there's all of the different manufacturers out there, and of course we got to go all the way down. You can see how many different manufacturers. There's just thousands and thousands of radios on here. But we're going to go down to where it says Zenith, okay, which of course is at the bottom of the page. Zenith radio. And we're going to look up our model H470. So we're going to scroll way down here, and you can see how many Zenith radios there are. And these are all old radios. None of these are new. So it just gives you an idea of what a history the Zenith Radio Corporation, as did Philco and some of the others. They made quite a few radios, and they made millions of some of these, you know, bunches of them. So this H741 happens to be a very, very popular one, or H725, I'm sorry. So H725, and you can see right there it is. Okay. And we can just click on the little disc here, and that downloads the manual, and there it is. Okay, so as simple as that. Now if you want to save it, I'm using Google Chrome, but I can download this as well, and I can save it, you know, in one of my radio manuals. I may even have it in here, I don't know. And we'll call this Zenith H725. So anyways, so we can go ahead and take a look at this, and you can see I'm going to open this up in Adobe so we can actually see it. Open with System Viewer. Open. I just thought you'd like to see that. I know I get a lot of different messages and so forth through the channel, people asking where I get my manuals, and there are several big ones, and for old radios this is by far the best resource. I get most of my radios from here. And the reason I'm also talking is I have my old RCA WR50B signal generator, and it's a vacuum tube signal generator, and my Voltomist. They're both warming up, and I've had them on for a while, but I want them to kind of temperature stabilize. If you notice, I have the output of the signal generator connected to the input of my new frequency counter way up there. I'll show you here, and you can see I have it roughly set to 455 kilohertz, and I'm just monitoring it because as these old tube signal generators warm up, they tend to drift a little bit until they stabilize. Now this one's pretty much done drifting. It hasn't drifted now for over 20 minutes, so I think it's pretty much where it needs to be. This thing's pretty close too. And with that in mind, we'll just go through this manual and we'll check out the so right there's your adjustment, okay, and it shows the actual layout of the chassis and all of the procedure right here. So let's see if we can bring this up just a little bit more. There we go. That's better. And we'll keep this in the background while we go and set up our radio. Okay. Now, the first thing I would like to do is get this radio set up on its side, kind of like this. And because we're going to actually be going, as you're going to see, into the bottom to connect our meters, and our test equipment, and then we'll be going into the top to actually make the adjustments. So let's just look this over real quick. I don't have anything plugged in the radio yet, but if we look here, first thing is this is for the AM section, this is for the IF, and what we're going to do is we're going to put a 455 kilocycle or kilohertz modulated tone. So modulated means it's going to have that 450 hertz tone on it. Okay, so we're going to put that on, and we're going to use a 0.5 or 0.047 microfarad capacitor. And I know I'm on one side of the camera, so I'm probably, you guys listening to stereo headphones, that drives me crazy when people do that. I apologize. 0.047 microfarad, and we're going to feed that into pin 7 of the 12AT7 converter tube. Okay, so let me get that hooked up and we'll be right back. Okay, so I have the radio all set up here, and I'm just going to go over the setup with you because a lot of people don't go over this. They just kind of hook it up and start testing things, and I think it would be interesting for you to see how it looks. So if we look here, normally where they're going to tell you to check the signal is going to be at the output transformer, the speaker terminals. The problem with that is you're always cranking the volume up so loud that you're blowing your eardrums out trying to trying to align the thing. So what I do is I go at the input of the volume control here. So you have your volume control, and right here is your input, and I connect right there. Now it's a much lower signal than after it's been amplified by the output tube, but that being said, it allows you to actually see the signal without having the radio turned up so loud that you can't stand it. Okay, so here's how it sounds with the signal going in. And you can hear I have a little bit of interference, and I'll turn it up just enough to hear some static in the background and to hear the modulation. Okay. static, that's what we're looking for. Now you don't need it anymore, so you have plenty of, plenty of everything there. We can shut that down. Now down here, as they were saying, okay, over in the directions, we're on pin 7 of the converter tube. Now pin 7, you get a little pointer. Pin 7 is right here on the 12AT7, and if you notice, there's a little wire coming out right onto this wafer switch, which had a big empty opening for solder. So I soldered this 0.047 to here, and then the other end, if you look, goes right into my connector here from the signal generator. The other end of the signal generator just goes to chassis ground. You can kind of see it under there. So those are the only two connections you need. So I'm checking from the input of my volume pot to ground, and I'm injecting the signal on the pin 7. I have it set that I hear a little bit of static, so I'm not overpowering the radio. You don't want to overpower the radio because you don't want the AVC circuit to kick in. That's the automatic volume control. So we don't want that. I have a decent deflection on my meter, so we're ready to do the alignment. Okay, so let me get the radio repositioned, and then we'll go through and do the alignment. All right. So get everything going here, and so we're going to start out at the first IF, and we're going to work our way all the way up to the last. So you have 1, 2, 3, 4, 5, and 6 adjustments for the AM IF. And again, you basically have the dial set to 600 kilocycles, or close to the bottom of the scale. Okay, so again, you don't have the dial on, you're not going to get a perfect. Those alignments where you get into that are a little bit later, but basically they want the capacitor almost all the way open. Okay, and again, you can hear we have our signal on, and what we're going to do now is we're going to start at the very bottom on this one. Okay, and going to look in there at the slug. I'm pretty sure, yeah, I don't know, I don't have the right size. Let me get a different alignment tool. Okay, that's better. Alright, so I'm going to just adjust that, and we're basically going to watch the meter go as high as it can go. Okay, so we're going to peak it out. So if we look, see there, it's going down, up. Oh, look, we're getting there. So right there's your peak. Okay, then we're going to go to the next one. Alright, and we're going to adjust it the same way. Just rotate it. Now that one was pretty close. Okay. Okay. Now we're going to go to our third one, and you can kind of see me on the edge of the screen getting into that. We're going to adjust that. Well, got a little bit more out of that one. Okay. And what you're going to find is usually from the factory, these are going to be, if nobody's been in there playing with it, it's going to be really close. The only thing you're going to compensate for maybe is some capacitors that may have slightly changed a little bit over the years. Okay, and let's do the last two. Okay. Right there for that one. Okay, so we had two of them that were a little bit low, but not terrible. And one of them, and the rest of them were all good. So that's really all there is to it. I mean, you've actually just witnessed the alignment of an AM receiver using vintage test equipment from that era. Okay, so that part's done. Let's go and look at the alignment instructions again. Okay, next instruction. 2 turns loosely coupled to the wave magnet. Okay, now you have to kind of understand what they're talking about. The wave magnet is their name for a AM loop antenna. Zenith kind of had this, it was kind of a promotional thing or an advertising gimmick. They called their antennas the wave magnet to signify that it can pull in the stations. But really all it is a loop antenna. And if we look here, this is your loop antenna. You can see it, and that's all there is to it. When they talk about loosely coupling, all they're talking about is you're just going to get a couple of turns of wire, and you're going to attach it to the signal generator, and you're going to go ahead and just hold it close to, or position it close to the coil. So let's get this capacitor out of here. Let's get the loop antenna set up, and let's show how we loosely couple the signal. So here's our setup. First of all, just to be able to get to things easier and to show you things, I've removed the speaker from the circuit, and in its place I've installed an 8 ohm, let's see if I can see it, 8 ohm 20 watt resistor. Okay, so it's just a dummy load. And the reason is, yes, you could disconnect that wire and just hook it right to your meter, but leaving that coil open like that causes problems with the input impedance of the output transformer and could cause problems with your output tube. It can actually put stress on the output tube. You definitely don't want to do that. So use a dummy load. Like I said, just the 8 ohm resistor will work fine. So loosely coupling, what are we talking about? So here's what I use. I just have a piece of solid wire, and you can see here it is. Okay, it's just a couple turns of solid wire, and it's just connected right to the input, or the output terminals of my signal generator. Okay, and I'm still at 455 kilohertz, and I'm still 400 hertz modulation tone. And you just take it, and by loosely coupling it, they mean put it in the proximity of your loop antenna, and that is going to give you your signal. Okay, it's just gonna, it's acting like its own little miniature radio transmitter. That's really what they want you to do, is they want you to make a miniature radio transmitter using your signal generator, and using this as kind of a little transmitting antenna. So let me get this turned around, and we'll get to the adjustments now. We're all set, and so we have our loosely coupled signal. We're at 1600 kilohertz roughly. Okay, and we're tuned in over here too with our 455. Okay, and what they're saying here they want a 1600 kilohertz modulated signal. So we're set at 455 right now. So what we need to do is we need to move this up to 1600 kilohertz. Okay, so if we look here, we're on the scale here. 1600 is going to be a different scale. So let's see here. Or one, which should be 1.6 megacycles is really what you're looking for. So we're going to adjust that, and we're going to bring this all the way down. Let's see where we're at. Here we go. We want on band C, and we want to bring it up to 1600. Okay, and that's going to be pretty close to 1600. Now we can use our frequency counter to set this, but I'm not going to bother with it. I'm just going to, instead of using the frequency counter, I'm just going to set it with the dial here, which is going to be pretty close. Okay, and that should get us where we need to be, and then we're going to get ready and get this thing set up. We're all set up now for this 1.6 megahertz, or the 1600 kilohertz. I have this roughly just a little bit from open, and that's getting pretty close to the end of the, the adjustment. Again, without the dial on the front of the dial face, this is a hard adjustment to do, so we're going to kind of rough it in. The signal generator is set at 1.6 megahertz, as is the tuner, and I'm loosely coupled, and you can see I just have the antenna kind of positioned over the loop, okay, to couple it up. Okay, and you can hear that we're tuned in. And basically all you do is I take this off now, and I go across my dummy load, so I have my resistor there, and I turn the volume up, until I get enough signal on there that I can measure it. And then I'm going to go to, and I even had to turn off the monitor, everything, because all the interference from the components on the bench will mess up this alignment. So you don't want anything turned on your bench other than your signal generator, your radio, and your meter when you do this. So right here is your for your dial scale, and this is 1600 kilocycles. Okay, and we're going to adjust this, and this is basically your oscillator adjustment. So you're going to set that until it gives you your 1600 kilocycles. Okay, and the way you do that is you would set it to 1600 kilocycles again on your dial. Okay, I know I'm repeating myself. The right way to do is put the radio together, set the dial, take it back apart, and then adjust it, because you can't reach inside the radio to do this part. Then you're going to go over to here, as you can see, and you're going to adjust for peak. So basically it's peaked out right now, but you can see if I go off channel, I get back on channel, and see you hit that little null point. Okay, and you can kind of see what I'm doing down here. I'm just adjusting that until this is right up at that null point, and once you get that there, that's set to your 1600 kilocycles. Okay, the next thing you're going to do is, once again, leave everything the same, but now we're going to move down to 1400 kilocycles. Okay, just like that. And I already went through and took this in and out and did this for you guys because it's kind of tedious. But basically, when I tune down here, you can see when I hit my station, so right there's about the 1400. And then I'm going to go onto this next adjustment, which is right here, and if I was off scale, I would peak it until it peaks out on the meter on that one. Okay, so really what you're setting, the first adjustment is your local oscillator. You're setting the frequency of your local oscillator, and then you're going down and you're setting a high end of the dial. And then our last adjustment, or our first adjustment, was actually, yeah, that's it on this one. On some other ones, this one does 1600 and 1400. Some of the other ones actually will have 1600 and 1400, and then another one at 600, or just 1500, something like that, a high scale and then a low scale. And basically, once again, you're setting your local oscillator, and then you're setting your RF, or your what's it called, for the low scale, for the antenna. Okay, for your antenna side. And basically what that's going to do is you're going to go back and forth on those two adjustments with this particular radio, putting the radio back in the case and taking it out, okay, and setting it until the dial reads perfectly. You know, when you feed it that signal, you're right on the dial, okay? So that's to set dial accuracy. Now, that's really all there is to the AM. Again, you just have your IF, which were those 6 slugs that we adjusted, and then you have your 2 adjustments here on your local oscillator and your antenna. And basically, by setting those 2 things, that's it. The AM is all set up. FM is a little bit trickier. Now, we're going to do it the old way. Normally, I would set this up, and I would put an S-curve up on my scope, and I would adjust it that way. But we're going to adjust this nulling out the discriminator. This is an old technique that a lot of these manuals use, and you're going to actually do a setup on this meter that you don't see very often. If you look down here on the meter, okay, let me turn this down. Right here it says 0 center, and that's actually for what we're going to do right now. We're actually going to disconnect any signal from our meter like this. Okay, this is what's going to happen later. I'm just kind of explaining it. And I'm going to set my 0 adjust so that I'm right at the center here. So basically, if I put, and I'm going to go to, I believe, DC volts, all right? I'm going to center this out. And basically, if I have a negative voltage, it's going to throw it this way. If I have a positive voltage, this way. And that's basically how we're going to set up our discriminator, okay? This is kind of written in it's actually the first step, and it basically says, I'm sorry, it's not the first, it's the second step. You're actually going to adjust your discriminator for a 0 reading, and that's what they're talking about when they're saying 0 reading, okay? So let's set up for this first one first. We want to get our, once again, our 10.7 IF set up, and we'll go from there. All right, and we should be able to turn some of our stuff back on because the FM shouldn't be as susceptible to noise, but I still don't like to have too much turned on when I'm doing all this.